Right now, a fleet of NASA spacecraft are turning their attention to an unusual object speeding through our solar system. This is a critical scientific update regarding the interstellar object known as 3 Atlas. As it moves through our inner solar system, this visitor from another star has become the subject of intense global scrutiny. It represents an exceptionally rare chance to study messenger from a distant unknown stellar system. On October 3rd, 3 Atlas executed its closest approach to Mars, a truly pivotal moment for observation. However, this remarkable scientific opportunity has collided with a terrestrial problem. This notice popped up all over NASA's websites on October 1st, stating that due to a lapse in federal funding, the agency would not be updating its public channels. In this briefing, we'll cover the details of this historic Mars flyby and why this observation window is so crucial. We will also review the most recent visual evidence we have, explain the direct impact of the shutdown, and finally look ahead at what to expect as the world waits for new data. So, let's begin with the flyby itself. This was a significant event, opening a new chapter in our observation of this object and providing a perspective that we have never had before. On October 3rd, 3I Atlas passed within about 2 astronomical units of Mars. Now, an astronomical unit, or AU, is the average distance from the Earth to the Sun. So, to be clear, this was an exceptionally close pass, only about 30 million kilometers. This proximity gave our robotic assets at the red planet an unprecedented opportunity to study it up close. To be precise, an interstellar object is a celestial body that does not originate from our solar system. It is a traveler from another star passing briefly through our cosmic neighborhood. This makes 3 Atlas a rare messenger potentially carrying clues about the chemistry and conditions of its distant home system. The timing and location of this flyby are what make it so scientifically vital. The observation point from Mars isn't just a matter of convenience. At this specific moment, it is absolutely essential. And here is the crucial point. Our ability to see 3I Atlas from Earth is now severely limited. From our vantage point, the object is in what astronomers call superior conjunction, meaning it positioned almost directly behind the Sun, its faint light completely overwhelmed by the solar glare. This table really clarifies the situation. As you can see, the Earth-based view offers obscured visibility. For Mars, however, there's a clear, unobstructed line of sight. This superior vantage point allows for the collection of high-resolution imagery and spectral data that are simply impossible to get from Earth right now. Now, let's examine the final pieces of evidence that were gathered from Earth right before the object disappeared from our view. This data serves as a baseline for everything we hope to learn from the new Mars observations. The final observation window from Earth gave us key images on 3 critical dates. On September 25th, we captured imagery just before the object was hit by coronal mass ejection. That's a massive eruption of plasma from the Sun. Then on September 27th, we got the first images after that impact. And finally, on October 2nd, one of the last viable images from Earth was recorded. The data so far has revealed an object with some highly unusual characteristics. Its velocity is immense, around 60 kilometers per second, which is far too fast for it to be gravitationally bound to our Sun. It has a vast diffuse coma, the cloud of gas and dust surrounding it, estimated at 700,000 kilometers across, nearly half the diameter of the Sun itself. And yet, it lacks the traditional long tail we associate with comets. Instead, it displays a strange sunward-facing antitail, which is very difficult to explain. And finally, its trajectory is remarkably aligned with the ecliptic plane, the orbital path of our own planets. A very strange coincidence for a visitor from another star. Taken together, these factors defy any easy classification. They've led observers like geoscientist Stefan Burns to label it the most bizarre object ever observed. This is precisely why the high-resolution data from the Mars flyby is so eagerly anticipated by the global scientific community. Which brings us to the major challenge complicating this entire event, the U.S. government shutdown and the resulting data blackout from NASA. The direct consequence of the shutdown is that NASA's public air-facing infrastructure has gone dark. Websites are not being updated, and critically, the normal flow of information from its deep space network, the global system of antennas that communicates with spacecraft, has been interrupted for many public and research purposes. However, while the data flow from key NASA assets like the Perseverance rover is interrupted, observation has not stopped entirely. Other international space agencies with missions at Mars remain fully active, and they are collecting crucial data during this flyby. The European Space Agency, China's National Space Administration, and the United Arab Emirates Space Agency all have active missions orbiting Mars. Their spacecraft are being tasked with observing 3 Atlas, ensuring this critical window is not entirely lost, even with NASA's current limitations. So with an international effort now underway, let's look at the path forward and what we can expect in the coming days, weeks, and months. The central question, of course, remains: when will we actually get to see the new high-resolution data from the Mars encounter? Well, the journey for this data from Mars to public view involves several distinct steps. First is acquisition, as the spacecraft capture the raw images. Second is a downlink, when that data is transmitted millions of kilometers back to Earth. Third is processing, where agency teams convert those raw signals into usable information. Only then can the scientific analysis begin, which will lead to the final release of findings. The timeline for this entire process remains uncertain. And looking even further ahead, another key observation opportunity is approaching. In early November, the European Space Age JUICE mission, that stands for Jupiter Icy Moons Explorer, will also be positioned to study 3I Atlas. However, due to that mission's own complex trajectory, we don't expect that data to become available until sometime in early 2026. The data set from this Mars flyby will be absolutely key to understanding this object. The data collected could fundamentally change what we know, and so the scientific community waits and wonders. When this information finally arrives, what secrets of its origin, its composition, and its long journey between the stars will 3 Atlas finally reveal?